Hi, this is Professor Fernandez again, and we are going to continue off and talk about lesson 1 in this video. In the previous video, I gave you a very quick overview. This is lesson 0. Here are some of the markings that are left over of what's going to be in the course. So now I want to actually start the course in earnest with lesson 1 and also continue scaffolding and introducing you to how the lesson notes work and how the videos will work. So this lesson is about three-dimensional coordinate systems. We are all very familiar with this. You know, just look around and we appear to live in a three-dimensional world. I say appear because if you believe the physicists, we're actually not quite sure. It might be 10 dimensions, 11, some other number. We don't know yet. But for our class, we're going to consider mostly three-dimensional space. We might veer into a higher dimensional space at some point when needed or when the proofs are simple enough to do in higher dimensional spaces. You'll notice this gray box here. This is going to be characteristic of all the lesson notes that you see. So it's a lesson preview. The idea is to give you a very quick summary outline of what's going to be done in the lesson. Often there will be 3 modules. In this particular lesson, there are only 2 because, again, it is meant to be an introductory lesson. And then I'll tell you as quickly as I can and, with as much useful elaboration and substance what's going to happen in each module. So in this lesson, the first thing that we're going to talk about is how to visualize three-dimensional space. And related to that, the algebraic properties of three-dimensional space. And then we'll learn how to plot points in 3D. In the second module, we will move on to plotting basic shapes like spheres, cylinders, and generalized cylinders. And that'll be this first lesson. You notice that there's a lot of white space here. What I will often, though not always, put here is a motivation for the content that we're about to learn by way of an application of that content. So in three-dimensional space, for example, there's not a lot that we need to motivate for because, again, we spend our lives seemingly immersed in three-dimensional space. But as the modules, as the lessons go on, the videos go on, and the concepts get a bit more involved, there will be stuff here that will help you to situate what you're learning in the course in a context that's hopefully useful. We will talk about applications to science, to social science. We will talk about just kind of mundane things that you might not have thought about, like when you're opening a door. Why not push or pull the door like in the middle? Why are the handles all the way at the far end of the door, at the other side of the hinge? So we'll talk about things that are intended to make what we learn more real, more relevant, more real world. Okay, so for this lesson, let's go ahead and get started with the first module, which is 3D Euclidean space. By way of introduction, right, usually in the modules, we will start off with a definition. This is very characteristic in math. What we want to do is we want to make sure everyone's on the same page. So we want to define the terminology, the notation we're going to use, and then go off and use it to talk about some useful insights or some relationships or state a theorem or do an example. So this definition, let's go through this and see what it's telling us. So first it says, let x, y, and z be real numbers. I'll review what the real numbers are in a minute, but you should be familiar with those. We will denote that set by r. So this might be a new notation for you. This is basically a regular r with an extra line through it is how we would write this out by hand. Great, so here's the actual definition. And the way that I've structured the notes, I will put this in bold. So what we're defining in this definition is three-dimensional Euclidean space. And what are we defining it as? Well, the set of all ordered triples, and we're denoting that set by R3. So symbolically, here is that definition. So that's a lot to absorb. You might be wondering, what is a triple? What does it mean to be an ordered triple? Why is there a 3? And what's all this? Right, and those are all perfectly natural questions. So to help you get a better sense for this definition, I want to step back a couple of steps and talk first about R. So this is our notation for the set of real numbers, right? So what does that mean? Well, so first of all, let's talk about these curly braces. So anytime you see this in the notes or in a math textbook, that means set. And a set is basically a collection of objects. So you can open your closet and you can think about the set of shoes you have. Or you can, walk outside your door and think about the set of cities in a particular state. Those are all examples of collections of objects, sets. So the things that are in sets we call elements of the sets or members of the sets. And R is a set. It's a collection of objects. It's a collection of numbers. So we say R is the set of X, and then this colon means such that X is a real number. Okay, so we're defining this new symbol as a set of things where those things satisfy a certain property. In this case, they're real numbers. You know of other number sets. You know the set of all rational numbers, ratios of integers, where the denominator is not 0. That's another set of numbers. So we could write that as set notation as well. So now that we have a sense of what these symbols mean, let's start connecting it to the visualization that we want to do in this module. So we know that we can visualize R as a number line. And here's 0. And then all the negative numbers are over here. All the positive numbers are over there. And, R is very dense. There are rational numbers. There are irrational numbers. So this is a nice interplay we have. We have the geometry visual on one side, and we have kind of the algebra, the set viewpoint on the other. So let's bump up the dimension here, and let's go to R2. This is the set of points, x comma y, such that x and y are real numbers. Okay, so some people, might view this as r squared. You could say that. There's something wrong with that. I'm just going to say R2 because when we visualize it, we are going to visualize it as 2 copies of R. And now we are moving on to Cartesian coordinates, right? So we're plotting points such that each component of the point is a real number. So that's how we're defining R2. So let's go ahead and visualize that. So we have one copy of R, that'll be the x-axis. And then we have another copy of R that's perpendicular to the first, and that's the y-axis. And then we plot points as x comma y. So the first number tells us how far to go along the first copy of R, the x-axis. The second number, how far to go along the second copy, the y-axis. So then you can see how we can continue this progression and get to this symbolic representation up here of three-dimensional Euclidean space. So R3, we're just going to add a third component. And we're going to say such that these three numbers are real numbers. Okay? So that explains the 3, right? There are 3 copies of R. And the visualization that's going to go over here, well, we would want to add a third axis that's perpendicular to the x and y axes. And if you've never seen this before, that might be a little bit of a stretch. So I'm actually going to break that down, take it a little slow so we know how to do that. But let me mention just briefly what I had mentioned a few minutes ago. We could abstract this and just talk right now about Rn. Why not? This is one of the joys of math. This is n-dimensional Euclidean space, where you have a point which has n components, 1, 2, all the way up to n, and each one of those numbers is a real number. I have no way to visualize that for you beyond R3 because we would need 4 or more dimensions, and it's just not very easy to do. But we can still talk about it in terms of math. So that's something that's actually really cool. We can certainly talk about things we can't so easily visualize. Anyway, but like I said, most of the time we will stick to R3. That was just an example to show you that sometimes if you see a pattern, you can just continue the pattern and just explore it. And a lot of times that's actually how math research is done. Okay, so let's try to figure out how to visualize R3. I have put this image down here that I'm going to walk through to help you do that for the first time. So if you have a paper in front of you or easily accessible, you could just grab that paper. You could draw the xy axes and the coordinate plane, and you could plot the point 3, 2. If you then stood above the paper, you stood up, and you were looking down to the paper, this is the image that you will see. At this point, there is no z-axis. You're just looking straight at the plane. If you now rotated your paper and kind of crouch down a little bit to the almost the level of the table, this is what you'll see. You'll still see the same flat paper, you know, and if you extended it in all directions, it would be the XY plane. There's still no up or down, and the point that you drew is still kind of on the table. Now, if you take a pencil and you just put it straight up on top of your paper, that is like the z-axis. So now we've kind of added a dimension, quite literally. And this dimension, as you can see by our construction, is perpendicular to the first two axes, the xy axis. So if you just remove the paper now and you kind of think of this abstractly, that is where we are going to be doing most of the math in this course, the R3 Euclidean space. So this is the XYZ axis that we get to. And this is something that we are going to spend a lot of time working on in the course. There are different ways to visualize this. The way I visualize it here is most common in math. Sometimes in physics, you'll see that they will keep the X and Y axes like this, and then they'll put the Z axis coming out. So you can think of that as if you were staring at a wall, and the wall was the XY plane, and then the Z axis was front and back, and that would be the Z axis. But again, we will stick to this representation of the coordinate axis. That's more common in math. Okay, so now you have a sense of what the coordinate axis looks like, and I'm just going to go back here and fill in that picture. So we have our nice progression here. So we have x, y, and z, so that's R3. And a point x, y, z here, it'll take a little while to be able to draw this because you have to go a little bit in the x direction, and you have to go a little bit in the y direction, and you have to go a little bit up in the z direction. Right, so I will often, what I'll do when I try to draw this by hand is I'll draw a cube and I'll put a point there to give you at least some sense that this point is not in the, you know, on the screen, but it's kind of lifted out of the screen a little bit, if you know what I mean. It has some depth toward you. So that's how you visualize R3. A few other things to tell you about before we go on to plotting points in R3. As we have seen by our construction, this is R2, this gray plane down here. So actually R3, right, all of this, the set of all these triples, contains R2. In fact, it contains multiple copies of it. You know, you could go to z equals 1 and you could draw the xy plane. There it is. You could go to z equals 2 and draw the xy plane. There it is. And you could do this up and down, right? So R3 has as many copies of R2 as you'd like. Another thing that you could do in R3 is you could say, you know what, I am not just going to talk about the xy plane, I'm going to talk about the xz plane, right? So the xz plane is this plane obtained by setting the y coordinate equal to 0. That's another example of what we're going to call a coordinate plane. The xy is a coordinate plane where z equals 0. The xz plane, coordinate plane, where y equals 0. And then there's also the yz plane, right, obtained by setting x equal to 0. So those are the three coordinate planes that we will refer to throughout the course. And then just like when you looked at R3, you had 4 quadrants. You had 1, 2, 3, and then 4. In terms of R3, you have what are called octants. So there are 8 regions we might want to think about. And really, the first octant is the only one that we'll ever spend much time in, so I'll just tell you about that one. That is where x, y, and z are excuse me, non-negative. So, you know, the non-negative where all positive is a little bit of a matter of convention. But if you think about, you know, the cube model again, it's actually kind of all of this. So everything that is in front of the XYZ axis, you know, coming towards you, if that makes sense. So that is what we define as the first octant. Okay, so now we have a lot of language and a lot of terminology. So I want to wrap up this first module by just showing you how to plot some points in R3. So this example is plotting these points, PQR, in R3. So first thing I'll do is I'll draw my R3 axis. It helps to add some depth to this. So, you know, quick little tips. If you are going to draw the XYZ axis like this and draw the axis for the x-axis like this, I find that it's not so helpful. And notice the subtle distinction, right? So the arrows that I drew over here kind of help to give your mind or your eye a sense that this is flat, and this is also flat. Whereas the arrows on the right-hand side over here don't really do that. So, my first tip for drawing points or in R3 or just drawing R3 is to try to make this seem like these arrows are flat. That will help. Okay, so P1, 0, 0. So this x coordinate is 1. So I'm going to go 1 unit in the x coordinate. And again, notice my little drawing there. I didn't do this because that's not, the way that x is going to go. X goes, or y goes this way, and I'm going to want to go that way in a minute. So these are just little tips for how to help you visualize, draw R3. So I go 1 unit in the x coordinate, 0 units in the y coordinate, 0 units in z. So basically, that's my point P. So I'm going to end up right there. Okay, so this is P. All right, let's try Q. So Q is 1, 1, 0. So in addition to going 1 unit in x, I also go 1 unit in y. So I'm going to start at P basically and then go 1 unit in y. So I'm going to end up right there. So that's my Q. And then R goes 1, 1, 1. So I'm going to go 1 unit up from where I was in Q, and that is over here. Okay. And again, I'm going to draw my cube here to help you further visualize what's going on here. This is z equals 1, and this was y equals 1. Okay, so this is my point R. Okay, so very, very simple example, just getting used to how to visualize R3, how to plot points in R3. Before I end the video, I'm going to scroll down a little bit, so bear with me. So here is a link for an applet that I linked to in the second example, which I'm actually going to pull up right now and just show you very quickly. It is something that you can use to plot points, functions. I'll introduce you to other applets throughout the course, which do similar things in R3. So I'm going to scroll back up to this example and then pull up that applet. So here is the applet. So this is the plane that you see, right? So the red dimension here is x, the green dimension is y, and the blue dimension is z. And I'm just moving this around with my finger here, you can move around the plane and better visualize some of the drawings that I was trying to make here. You can also try to plot points. If you click up here and you click on point, you can just click somewhere in the plane and then you can move things up or down. And then once the point kind of initializes, right, you can also continue moving it up or down. And if you tap it, you can then move it in other directions, right? So you can see, and then when you tap off site, you can go back to seeing what the point looks like and rotating things around. So I encourage you to spend some time with this just to get accustomed to what the point plotting in R3 looks like. You can see over here on the left-hand side, if I click on this, I could try to edit this. So I am on an iPad, so it makes it a little hard to do, but I could change the coordinates here to 1, 1. In other words, I'm trying to plot the point R that we just plotted to visualize that for you, 1, 1, 1, and then I'm going to hit enter, and there is the point. So it is 1 unit above the XY plane. It is also, if I look on the XY axis, it is, here X is the red axis, Y is the green. It's 1 unit to the right, 1 unit up. Okay. So again, I encourage you to plot points here to kind of explore. You can zoom in and out to help you figure out a better orientation for the points you're plotting. So I'm going to go back really quickly to the lesson notes. So that's it for this video. So in the next video, we are going to continue and talk about plotting shapes in 3D. Like we said earlier, spheres, cylinders, and generalized cylinders is to start off with. So I'll see you then.